I'm Carl Anthony, Managing Editor of AutoVision News, and welcome to AutoSens Insights. We're speaking today with a longtime member of the AutoSens family, Beert de Kooi, the founder and CEO of ESPROS. And Beert, good to see you again.
Hello, Carl. Good to see you again. Good to see you during these very weird times we are living in. And yeah, usually we do this interview face by face.
Yes.
Not possible this year.
I do remember last year when we met face to face in Brussels. You had two brand new products. We actually had two cameras on display in September in Brussels when we met last year. And you had said that you were very busy with things. So can you give us an update? What is the latest with ESPROS?
That was really something that was a milestone for our company because we could really show the performance of our CW TOF imagers. And as a result, we won very, let's say, demanding, interesting, nice projects where the performance of our CW TOF chips are required because of sensitivity and because of ambient light suppression. There are outdoor applications, and you really have to have a stable operation on long range and full sunlight, and that's challenging, and that's exactly the domain where we are in.
Okay, so with that in mind, Beert, for our viewers who may not be familiar or who are meeting you for the first time, give us an overview of ESPROS. Tell us about the company.
ESPROS is basically a semiconductor manufacturer, a little bit simplified. Our focus is on CMOS CCD imaging technology. And CMOS CCD is a technology that allows to do manipulation of analog signals in the charge domain. So manipulation means accumulation of charge or subtraction of charge. So these basic mathematical functions, or binning, then it's a multiplication of charge. And all these operations are noise-free. There is no additional noise. So it's the best, from a noise standpoint, the best possible technology you can have to detect photons and produce at the end digital output. And we developed this CMOS CCD technology based on standard silicon CMOS technology, and that development started 14 years ago. And since we had then this technology established and supplies or supply chain established, we started to develop and produce imager chips. And CMOS CCD combined technology is ideal for time-of-flight applications.
And Beert, that is a perfect segue to the next question, because I see the banner behind you, time of flight done right. I always like it when we talk about this topic, but let's explain time of flight more. What is time of flight, and why is it important?
Well, we as humans, we are able to see our environment, the scenery in 3D. And we do that with the stereo vision. We have two cameras with two eyes and a powerful computer which correlates these two images to a 3D image. That's a fantastic thing. Works very well, but the problem is that if there is no structure in the scenery, we cannot, let's say, estimate the distance. We need structure in the scenery. So, for example, if we look to a white wall, we don't see, we cannot estimate the distance. Like when you are skiing in haze illumination or fog, then you don't see the bumps on the slope, and it's really hard to ski. And that's let's say a drawback of our vision system. And TOF does it a little bit different. It's just one camera, but an illumination which illuminates the scenery and measures the time the photons need to travel from the illumination to the scenery and back to the camera. And this time of traveling is called time of flight TOF. Okay, and that's what we basically doing. Let me add one more sentence here. There are two technologies or two concepts you can do that. Basically, one is direct time of flight. We call that PTOF, pulsed TOF, where you emit a very short pulse and then really measure the time the photons travel to the scenery and back. And the other concept is CW TOF, or indirect time of flight, where the illumination is modulated, continuous modulated typically, and then the measurement principle is to measure the phase shift of the received light.
Right.
We do both.
Of course. Now, Beer, with regard to the time of flight camera, on your website, and I want to encourage our AutoSens viewers to look at this, but on your website, you have something called the time of flight ecosystem, and it goes through the main parts of the time of flight ecosystem. We talked about illumination, but there's software, there's the power supply. Can you tell us a little bit, can you tell our viewers a little bit about this time of flight ecosystem?
Yeah. As I said, we are a semiconductor manufacturer, and our main products are the imagers. This is, you can say, it's the heart of a time of flight camera or a LiDAR sensor. It's a LiDAR scanning sensor. It's the same. And the heart is really the imager, because it has to kind of fishing out from all the photons which arrive to the receiver, the right ones which contain the information of the distance. Okay, that's one part, and that's in the imager chip. But there are many other domains which have to be mastered by the engineers which implement the imager chips into a camera. For example, the lens in front of the imager. If the lens is not appropriate to the application, it does not work. The whole thing does not work. And the ecosystem actually shows which domains have to be carefully engineered, that at the end of the day, a good time of flight camera comes to the market. And we, as a camera chip or imager manufacturer, we support our customers in this implementation, not just by implementing our camera chip, but also how to build the whole ecosystem around this imager.
So Beer, that reminds me, just as you were speaking before, you said a few key things, talking about engineering, talking about the ecosystem, and then talking about your customers. So tell us a little bit about your customers. Who are they, and how do your innovations at ESPROS help your customers every day?
Looking first to the markets, in which markets are our customers, and it's industrial. That's let's say somehow relatively simple approach, because there are a lot of engineers which already have developed the optical sensors for tens of years, decades actually. But then there are new domains like mobile robotics, very interesting market, fast growing market, where these robots need to find their path through a hospital or a university campus or a logistics center. And to do so, 3D cameras are a must to have. And another market is automotive. I'm by purpose separated these markets a little bit because the requirements of our customers are different from the market. So when we deal with customers or the engineers which do industrial products, which develop industrial products, then they have quite a good knowledge about how to implement optical or optoelectronic sensors. They have quite a good knowledge. But what they don't have typically is the specific know-how regarding ToF. It needs some additional know-how. And we see our job to support these customers that they are fast in implementing 3D time-of-flight technology into their sensors. Okay, so that's one thing. With the mobile robotics, it's a little bit different. These customers typically they are not looking for a camera chip; they are looking for a complete solution. They would like to get a nice point cloud, clean, no noise, all artifacts eliminated, and then they can do the rest. They operate with the point cloud. So that's the second domain we are in. We develop such camera modules which provide these point clouds. You have seen them at the AutoSens in Brussels.
Yes.
And then the automotive customers, they're also different. They have a very, very, very good know-how about what they're doing in optoelectronic and in implementation of ToF and LiDAR. They are really the experts as we have recognized them. And it's nice to work with these people because together with them, you can go beyond the limitations. What we cannot do with let's say an industrial customer is it's somehow limited.
Right. And speaking of your industrial customers, Pierre, in just an industrial setting, in the June newsletter that you sent out, there was a really interesting article about forklifts with the ESPROS time-of-flight technology, about these self-driving forklifts that had to navigate a factory or navigate a logistics center. So can you tell us a little bit more about that?
Yeah, that's really interesting. The autonomous forklifts. Okay, the forklifts. Let's start here. The forklifts they all have the problem for the drivers that the driver cannot see into every corner, especially when his lift is very high up. He cannot see into the shelf. So a 3D camera helps a lot to explore the area there and to make sure that the goods go to the right location without any damage, without any collision.
Yes.
When it comes to autonomous forklifts, then the difficulty, or let's say the degree of requirement increases dramatically because typically in such an environment, it's always mixed. There are some autonomous robots or forklifts or autonomous guided vehicles, and also people. So, sure. And you have to make sure that there is no collision at one point of time with shelves or with other things, but even more, and that's the point, not with people, not with the humans which are in the same operating or working in the same area. Yes. And the key point here is fail-safe. These 3D cameras, they have to be fail-safe. They have to fulfill the machinery directive so that no accident happens together with such a forklift. And that's a next generation challenge which all of these camera manufacturers are facing. And the design of our imagers is made in a way that such cameras can be implemented Seal 2 to achieve the required safety level. And we also support our customers how to implement a camera that it achieves Seal 2. We actually already implemented cameras which have that safety level.
Of course. So, Beard, when I saw the newsletter in June and then just listening to you explain this again, one question our AutoSens viewers may have is, how can we take what we have in the factory with the forklifts and apply that to roads for either future ADAS systems or for fully autonomous driving platforms? How do you make the transition and the application from the factory to the everyday roads?
Basically, on our side, there's not much additional work needed. It's more based on, let's say, environment protection, protection from the environment, so that the sensor can operate when there's, for example, rain or so. Typically, you don't have these issues in a factory, or when people are washing the car with a high pressure spray. So it's more these aspects, but the safety aspects are exactly the same. There's no difference.
Right. Beard, it's always a pleasure to talk with you. I want to encourage all of our viewers to visit your website to learn about the time of flight ecosystem, to visit all of the resources here that you have with the AutoSens conference. Before we finish, Beard, is there anything you'd like to add or anything you'd like to summarize? Again, is there anything we may have missed?
Let me just add, stay healthy.
Yes.
Stay healthy, and do not overestimate the turmoil the media generates with the pandemic. if I'm allowed to say that, because I think the economic damage would be unbelievable, and that would and it becomes unbelievable, unfortunately. That's my belief. And at the end of the day, people have to survive somehow, and if at the end of the day every second is jobless, it's not really a good development. Okay, that's a political statement regarding technology. If you allow to add something here, I'm pretty sure that I pursue this technology for 35 years, but I'm pretty sure that we are now very, very close to much more autonomous whatever helpers, which help the humans, and as what we see is that this pandemic supports or let's say increases the speed of implementation. It's really very high pressure.
Beard, it is always wonderful talking with you in Detroit and in Brussels in person, and this time virtually. So I always enjoy our discussions and our conversations. From all of us at AutoSens, we want to wish you and the ESPROS team, we want to wish you the best of luck going forward. Thank you for taking time to talk with us today.
Thank you, Carl. Thank you.
We're speaking today with Beard Decoy, who is the founder and CEO of ESPROS. For more great content from AutoSens, visit our hub or our YouTube channel. Just search AutoSens.